Assalamu alaikum dear students. Today we are going to start a unit 7 properties of matter, assignments and numericals. Now the first one assignment is a block of concrete weight 900 Newton and its base is a square of sides 3 meter. What is the pressure does the block exert on the ground? Means force is given to you and the length of one side is given to you. Look at in a diagram that a square is mentions to you, which is a look at this one square, this, and all the sides has carry a 3 meter. L equals to a 3 meter. Clear? We know that a area equals to a 3 L multiplied by L, length into length, which is a 3 meter. 3 meter multiplied by 3 meter, which comes a 9 meter square. So required data is asking to what pressure we are going to find out. In the formula we know that a pressure equals to F by A. In a given data, F is given you a 900 Newton and the area is 9 meter square. 900 divided by 9 is a 100 comes 100 Newton by meter square. We know that a Newton per meter square equals to a Pascal. So pressure equals to 100 Pascal. Now the assignments 3.4. A geologist find that a moon rock whose weight is 90.9 Newton and has an apparent weight is a 60.6 Newton. When submerged in a water, what is the density of the rock? Again, look at this question and understand that a geologist finds the moon's rock weight 90.9 has apparent weight is 60.6 Newton weight when submerged in the water. Means when you submerge in the water, then the weight is a 60.6 Newton. Means the weight in water is a 60.6 and weight in air is a 90.9. We know that a density of water is 1000 kilogram per meter cube. So we can also write is a 1.0 multiplied by 10 raised to power 3 kilogram per meter cube. Required data is a density of the moon rock. Formula we know that F equals to WA minus WB. Original formula is a WB equals to a WA minus WB. When we rearrange that, it comes a F equals to a WA minus WB. Why we are finding a force? Because the formula of finding the density is a W by F equals to a density not divided by density. In this formula, force is absent. So first we find a force. Solution, when we do a solution, first we finding a force beyond force. F equals to a WA minus WB. Put the value and answers gets 90.9 Newton minus 60.6 Newton and the answers comes at 30.3 Newton. Now we are finding a density of moon rock. So using this one formula, W by F equals to a density of moon divided by density of water. Force 90, that's why we have first find the force. We have find out which comes at 30.3. So rearrange this formula and the density equals to W by FB multiplied by density B. Putting the value 90.9 Newton divided by 30.3 multiplied by 10, 1 multiplied by 10 raised to power 3 kilogram per meter cube. So divide a 90 by a 30, answers comes a 3 multiplied by 1.0 multiplied by 10 raised to power 3 kilogram per meter cube and the density comes a 3 multiplied by 10 raised to power 3 kilogram per meter cube. So the results comes a density of moon rock density naught equals to a 3 multiplied by 10 raised to the power 3 kilogram per meter cube. Now the assignment number 3.5. An elastic wire, the length is 2 meter and the cross-sectional area 0.02 meter square is stretched 0.01 meter. It's there is written by mistakenly wrong that its the value is a 0.01 meter by a 300 Newton weight. Calculate the Young modulus of the material. We know that a Young modulus formula. First we writing given data that there is a clear written to you that a length equals to a 2 meter. Area equals to a 0.02 meter square. And this is the extension, a stretch. That means change x equals to a 0.01 meter and the weight of force F equals to a 300 Newton. Required data is a Young modulus. Formula of the Young modulus F into L divided by A into X. So put the value of L 300 Newton, F 300 Newton, L is 2 meter divided by area is given to you as 0.02 meter square and the X is given to you as 0.01 meter. Multiply 300 into a 2 comes a 600 and a 0.02 meter square multiplied by a 0.01 meter. The answers comes a 0.002. Divide a 600 on a 0.002, the answers comes a 3 lakh Newton per meter square. You can write a 3 lakh in a scientific notation, and it comes a 3.0 multiplied by 10 raised to the power Newton per meter square. So the young modulus answers comes a 3 multiplied by 10 raised to the power 5 Newton per meter square. Now we are going to calculate a numerical number 1. The rectangular glass block is a dimensions 30 centimeter by a 5 centimeter by 100 centimeter, weight 37.5 Newton. Calculate the least and the greatest pressure it can be exerts when resting on the horizontal table. So W equals to a force equals to a 37.5 Newton. Length L equals to a 30 centimeter. The 30 centimeter, it's a centimeter, not in the meter. The standard unit is meter. So we are going to shift a 30 centimeter into a meter. So what do we do that? Divided by 100. 30 divided by 100 comes 0.30 meter. Now the width is given to a 5 centimeter, and 5 divided by 100 so comes a 0.05 meter, and the height h equals to a 10 centimeter, and 10 divided by 100 comes a 0.10 meter. Required data is least pressure and the greatest pressure. Formula, we know that the formula of the pressure is pressure equals to F by A. Least pressure, PL. When always the pressure is least, means that area is greater. So when the area is greater means the length is maximum. So PL equals to F divided by A. We know that the area formula is L into H. Putting in the values that are force given to a 37.5 Newton divided by a 0.3 multiplied by 0.1. Answers comes a 0.03. Divide a force 37.5 divided a 0.03. The answers comes a 1250 Pascal. Now the second part is the greater pressure. When the pressure is greater means the area is smaller. So we know that the pressure equals to F by A. So the area is smaller. That's why the formula comes a W into H. Put the value of force 37.5 Newton and the W value is 0.05 meter multiplied by a height is a 0.1 meter. Those answers comes a 0.005. So 37 divided 0.5 divided by 0.005, the answers comes a 7500 Pascal. So the results of the least pressure PL equals to 1250 Pascal and the greater pressure 7500. Now the numerical number 7 is the smallest piston of the hydraulic lift is an area of 0.02 meter square and the car weight is 1.20 multiplied by 10 raised to the power 4 Newton. Sit in the rock mounted on large piston. The large piston has an area of 0.90 meter square. How the large force must be applied to a small piston to support the car. So the given area that you have a given of area A1 equals to 0.20 meter square. The force F2 equals to 1.20 multiplied by 10 raised to the power 4 Newton. And the area 2 is given to a 0.90 meter square. Required data that they are finding that what is the force applied on the small piston? Small piston is the A1, so the required force is a F1. Formula is a Pascal law that a P1 equals to a P2 F by A. So P1 equals to a F1 by A1 and the P2 equals to a F2 by A2. By rearranging the formula, F1 equals to a F2 divided by A2 multiplied by A and putting the value. The formula or value of F is 1.20 multiplied by 10 raised to the power 4 Newton into a 2.0 meter square divided by 0.90 meter square. So the answers comes at 2400 divided by 0.90. And when you are going to divide, the answers comes at 2666.6 Newton. Convert into a scientific notation, the answers comes at 2.6 multiplied by 10 raised to the power 3 Newton. So the answers comes are F equals to a 2.6 multiplied by 10 raised to the power 3 Newton. The next one is a numerical number 5. A block has a fully immersed in water. Before the immersion, the block weight is a 30 Newton and while immersed, its apparent weight was found to be 25 Newton. Calculate the upthrust force, weight of the water displaced, volume of the water displaced, volume of the block and the density of the block. Lot of things we are going to be find. But in a given data, the weight in air, WA equals to a 30 Newton. Weight in water, WB equals to a 25 Newton. Density in water, equals to 1000 kilogram per meter cube, and the gravitational acceleration G equals to 9.8 meter per second square. So the required list is required data: upthrust force FB, weight of water displaced WW, volume of water displaced VW, volume of block V naught, and the density of block mu naught. So the formula for the first FB equals to a W minus WA minus WB, second FB equals to a WW, and the third one is a W divided by FB equals to mu naught divided by mu B, and the density equals to M by V. The volume equals to a mass by density, and the volume equals to a volume of water equals to a volume naught. So first we are finding a upthrust force beyond force. FB equals to a WA minus WB. Putting the value, we know that WA equals to a 30 and WB is a 25. When we are going to subtract, answers comes a 5 Newton. Now finding a weight of water displaced, we know that F equals to W. So that's why F equals to W, the FB equals to a WB. So the FB is a 5 Newton. The W comes a 5 Newton. Now we are finding a density of a block mu naught. Formula is W by FB is a mu naught divided by mu B, and the when we rearranging the density comes a W by F is the density B. Putting the value 30 by 5 multiplied by 1000, the answers comes a 6000. Now we are finding the volume of water displaced. We know that a volume equals to a mass by density, but there is a mass is absent. First we are finding a mass. Mass equals to a W equals to mg. Now by rearranging that, a mass equals to a W by gravitational force 5 divided by 9.8, the answers comes a 0.51 kilogram. So the volume mass, we have find out the mass, putting in the value volume equals to mass by density 0.51 divided by 1000, and answers comes a 5 multiplied by 10 raised to power 4 minus 4 meter cube. So the density comes that.